recommender systems in production can be really hard. For a robust recommender system, you would need an existing data infrastructure to make this work, user interaction logs, and for that, actual users using your app. You would need to train models, and of course, a whole self-improving pipeline and life cycle of this recommender system, which just keeps on learning out of all this data. Now, this can be very difficult actually for very small apps like some side projects and all of that. So if you ever built like a small side project, which would need like a small recommender system, a lot of these things wouldn't be actually really, plausible to implement, right? Oh yeah, and you would need a robust backend. I guess I forgot this last point. But yeah, but it doesn't actually have to be this way. And in like a small last side project, I actually found out a really simple way to implement like a very basic recommender system just from the start, and that's what I will share today. So, Assalamu alaikum wa rahmatullah. My name is Yunus, and today I will show you how to actually implement a simple recommender system without even users, or like without even any initial users or an entire backend. So I was able to do the system just basically with, like a Jamstack. Wow, that feels old. I don't know if a lot of people talk about Jamstack still today, but basically just like a front end app with some back end APIs, and not an actual back end system. And yeah, that's what I will teach you today. Uh, but first, I just want to say I'm not selling anything. Like, you won't in the end find anything like, oh yeah, join my course or something like that. I'm just teaching this as for the sake of teaching, you know. So maybe if I die, it would benefit someone. I don't know, inshallah. First of all, I want to go through some quick recommender system theory. Basically, there are two main types of recommender system, and there are some people which basically try to overcomplicate it, but these are really the two main approaches that you can go with, okay? So first, the collaborative filtering. This is what you probably usually understand with a robust recommender system like from YouTube or TikTok or something like that, right? And what it uses there is something called a user interaction matrix, which looks like this, where you have a list of users and a list of items, right? Items can be like like videos or like things, I don't know, books from Apple Books or uh, audio books from Audible or something like that, or even like an item to buy in Amazon, right? It can be anything really, an item. And this user item interaction matrix actually checks, or it has as data how much this user interacted with this item. And this can be different stuff, like for example, views or like a rating. So from 1 to 5, for example, here is a rating from 1 to 5, or it can just be like and dislike. You know, this, by the way, like understanding this helps you also understand more how like these algorithms work, like YouTube and TikTok and all that, right? That's why these likes, for example, are so important for the algorithm to know what you actually like, because it uses this user item interaction matrix for that, right? But for that, you actually need users. And a lot of side projects that you might have done don't have any initial users, and that is a problem, right? Uh, or if you just want to have like an initial recommender system without users yet, and then try to improve it later, like how are you going to show some recommendations then, right? If you don't have this yet, like you don't have any users and you don't have any interactions yet. So, and also here's also a big problem with collaborative filtering with these types of methods, is that they have a cold start problem. Meaning, if you go, for example, onto YouTube with no account, they don't know what to show you yet, right? They have no idea what to show you. That's because they don't know what you like yet, because they rely on this heavily to know like what you actually like. And there are a lot of different wait, let me put the camera away here. Okay, there are a lot of different kinds of collaborative filtering. There's memory-based and model-based. We will actually not go into this, today. Maybe I'll show like in a different project how we could do this, right? But I really just, wanted to show how like you can put a very simple system online, and therefore we will go to the content-based approaches. Okay, and that's all we'll talk about today. For that, actually, I just want to show it right here. Okay, so how content-based approaches works is you try to get an item and make it into a vector somehow, right? So imagine we have here this burger, and we can make this into a vector by giving it some numerical values which classify this burger. For example, is vegan is 0, it's not vegan, calories is 800, and spiciness is, let's say, 5, right? And you can do that for many different items, right? And what you would do, what you would have then actually is you can then have like a coordinate system where you have different items on here, and you can actually see how close they are to each other, right? So let's say here we have here hamburger. I'll just like make it like this, and then maybe something close to it would be a hot dog, right? So hamburger, hot dog. Something maybe further away from it would be fries, like that, okay? Now, if a user, for example, likes hamburgers, okay? So user A likes hamburgers. What you would do then now as a recommender system for the content-based approaches is you would just try to basically see which other vectors are close to it, right? So it basically tries to calculate the distance to the hot dog, and it tries to calculate the distance to the fries. And then it says, okay, the hot dog is a lot closer than the fries. Oh, there are 2 hot dogs. Okay. This is a lot closer than the fries, right? Actually, there are 2 ways of doing this. So the way that I just showed you is where you would try to compare items with different items, okay? Another way that you can actually do then later is you can actually also try to capture a user based on this vector. Let's say user A now, okay? So this is user A. He actually likes vegan stuff, which is a bit lower calorie and has no spiciness, okay? This is the preference of the vegan, okay? Or of user A, sorry. And what you can do now then is in the same coordinate system, you just put your user A, okay? You put your user A in the same system, and what you would then do is you would try to find items which are closest to the user, right? So again, here it goes through each item and sees fries is the closest. So it would give the user A fries as a recommendation, okay? So this is how it works. And I will show you now, inshallah, how you can actually really implement this super simply. The stack that I used to implement it as front end, it doesn't matter, I use just like React for my case, right? You can use any other framework or no framework even if you don't want that. And for the backend, I actually did it all with SQL, okay? And I'll show you now how I did it. So the project was actually to I had a library of audios, okay? Audio library. And it was basically like seminars and lectures and all of that, right? And I wanted to actually create some sort of recommender system to recommend different lectures and seminars and different like lessons based on the one that you are on right now. So the way that I did this actually, I actually first converted all of them to text, okay? The way that I did it, actually, I used Google Colab to just run Whisper, since it's cheaper. This is a good tip, by the way. Use Google Colab Pro with Whisper instead of using the Whisper API from OpenAI. It's so much cheaper, actually, this way, You get so much more out of it. if you just use Google Colab with Whisper instead of the OpenAI API. So what I did here is I converted all the audios into using Colab Whisper. I convert all these audios into text transcripts, okay? So transcript. And what I would then do with the transcript actually is I would make the transcript then into summaries, okay? So for that I would just use the OpenAI API, okay? So here I just used like I'll just say LLM, and then I'll have here summary, okay? Now what I did here now is actually first I tried to use LLMs for actually data augmentation. So the way that I did this is I used LLMs to get other stuff. So out of the transcript or the summary, I forgot if I did it directly from the transcript or just the summary, but I basically tried to get a category. Okay, so I like had a fixed amount of categories, like for example, I don't know, math, English, and all of that, right? Or topic, let's say topic. And here I then had tags, right? So through the LLM, I basically generated and augmented the data, okay? What I did then actually for the pipeline is, and this is all, I just had to do this one time, right? It was just a one-time thing. And then out of all of these, I basically created a text that looks like this. So what I did is I took all the information that I had from this and put it into its own like string, right? Its own template string. The reason I did it like this actually is for the next step. I forgot to explain this. So what I then did with this actually is I just simply put this into I just created embeddings out of this, okay? So I just use OpenAI embeddings, just easiest thing, right? I mean, I could also have used Word2Vec or something like that, right? But the reason this is important and not just doing the whole transcript, even though the transcript might have more information, is because the transcript would have huge embeddings, And this way is actually a lot more regulated because maybe one file has like small embeddings, like it doesn't have much text, it's just a 10-minute lecture or something like that. And then there's another one which is a 2-hour lecture, right? So it's difficult to compare like that, and also like it's a lot more data that you have to save in the database. And I saved all of this data then just simply in a Supabase SQL, like Postgres database, okay? I created embeddings out of this. And these embeddings were then the vectors I had for here. So all that I had to do then is create a single SQL function at the end. And the SQL function, all it does is it recommends the next K amount of items based on the item you watch. So what you would do is you would give it a item ID, okay, item ID. And out of the item ID, the function would then go and look at its vector that it has, like the embedding of the item, and search up similar, closely connected vectors from it. And then it would just recommend a list of vectors. And that's it. And all I then had to do is call this function in my React app using Supabase. And that's it. Super simple system. You need zero users to start with. You don't even need a backend. I used SQL functions, right? And this is just like a one-time thing, right? I mean, if you want to automate it, you can just simply automate it every time like a new lecture is uploaded or something like that, right? I mean, for me, it wasn't that needed. Like I would have had to like do this once every, I don't know, month or something like that, right? To add it to the recommender system. So like this wasn't too much of a problem, but I really hope this helps, since I also see there isn't much information actually on practical knowledge on how to actually then implement these stuff, right? So it was very interesting. Actually, I played around with this then too, because I then used PCA, and PCA is like a dimensionality reduction algorithm, right? To reduce these like embeddings. I think I used a dimension for the embeddings like 752, I think it was, something like that. That was like the size of the embeddings, and then I used PCA to reduce it down to 2, and then I actually just looked at it, how everything looks in a simple 2D, graphic like this, and I actually then categorized it by topic, or for me it was category, right? Like as a label, right? It was super interesting to look at actually. Maybe I can show it sometime. But yeah, I hope this helps anyone who was struggling with adding a small recommender system or something like that. Assalamu alaikum wa rahmatullahi wa barakatuh.